Hello everybody, I would like to welcome you to our 16th video in the pre-algebra playlist, and in this video we are going to go over the concept of inequalities. Now so far we have dealt with what are known as equations, and equations are known to have contain the equal sign in them. But the only difference between equations and inequalities is that the inequality will not have an equal sign in it. Instead, an inequality will either have a greater than symbol, a less than symbol, a greater than or equal to symbol, or it will either have a less than or equal to symbol. Now I'm going to rewrite these symbols over here, and right next to them I'm going to write down how to read them, and then we'll do a few examples. So if you encounter this inequality sign over here, where the open mouth is pointed to the left, this is read as is greater than. Conversely, if you encounter an inequality sign where the mouth is opening to your right, then this is read as is less than. If you encounter an inequality sign where the mouth opens to your left, but there's also a little dash right below it, like this over here, this is read as is greater than or equal to. And lastly, if you encounter an inequality sign where the mouth is opening to the right, but there is also a little dash right below it, like this over here, this is read as is less than or equal to. Now you might be wondering what I am referring to when I discuss these inequality signs. What I mean is that if you have an equation like this over here, this is an example of a false equation because 4 is not equal to 5. But if you have something such as 4 is less than 5, this is an example of a true inequality because the statement is read as 4 is less than, due to the mouth opening to the right, than the number 5. So basically, the mouth opens up to the number or the expression that is greater than the number. Now, I live in Florida, and the way I remember it is wherever the mouth of the alligator opens, that's the greater number, because the alligator is always hungry and wants to eat more and more. Similarly, if you have something such as 3 plus 8 is equal to 9, this again is an example of a false equation because 3 plus 8 is equal to 11. But if you have something such as 3 plus 8 is greater than 9, this is an example of a true inequality because 3 plus 8 is 11 and 11 is greater than 9. Also, something such as 3 plus 8 is greater than or equal to 9, denoted by this symbol over here, is also a true inequality because 11 is indeed greater than 9 or it's equal to 9. Now on the next page, I'm going to go over how to graph inequalities on a number line. In this example, let's say you are asked to graph the inequality a is greater than 8. Now when we encountered graphing on the number line in the first video of the pre-algebra playlist, all we really did was that we graphed single points on the number line. So if I wanted to say let's graph the number 1 on the number line, all I really did was that I put a point or a mark on the number 1 on the number line. But when it comes to inequalities, there are more than one solutions. This is true most of the times. For example, if I say a is greater than 8, number 9 satisfies this inequality. So does the number 10, so does the number 11, and so does the number 12, and so on and so on and so on. Basically, any number that is bigger than 8 does satisfy this inequality. So the way I go on about graphing a is greater than 8 on my number line is that I draw my number line like this over here with the 8 on it. The next thing that I do is that I put an open mark on the number 8. Now, I would put an open mark if there is no dash below the inequality. Basically, if the inequality is read as is greater than or is less than, I always put an open mark when I'm graphing the inequality. On the other hand, if the inequality reads is greater than or equal to, or if it reads is less than or equal to, I will always put a closed mark on my number line. The meaning of the open mark or an open circle on the number line tells me that the number 8 is not part of the solution that I'm looking for. So the number 8 is excluded from all the possible solutions to the inequality. The next thing that I really need to do is that I simply draw a line in the direction of the solution. So the direction of the solution is all numbers greater than 8. So basically all I really need to do is draw a little dashed line pointing away from the number 8 into the direction of the solution. So this right here is how I would graph the inequality a is greater than 8. One way that might help you remember in which direction to draw the arrow is to look at where the inequality arrow points. In this case, the inequality arrow points to the right, so you need to draw the arrow or the solution to the right. Let's say you wanted to graph the inequality of c is less than 2. So the first thing that we really need to do is draw the number line. The next thing that I really need to do is figure out if I'd have a closed dot or an open dot on top of the number 2. In this case, I will have an open dot because there is no dash below the inequality sign. And lastly, I need to figure out whether I'll be drawing the arrow to the right of the dot or to the left of the dot. In this case, the arrow, the tip of the inequality, is pointing to the left of the number 2, and therefore I'm going to basically draw a dash like this over here, or a line to the left of the number 2. And this really makes sense. If I pick a number that is left to the number 2 on the number line, such as -1, and I replace that with the number c, I get -1 is less than 2. So this inequality is true. Similarly, if I pick another number such as 0, I read it as 0 is less than 2. This is also true. In this example, let's say you wanted to graph the inequality b is less than or equal to -7. The first thing that we really need to do is draw out the number line. But in this number line over here, we realize that the number -7 is located between the numbers -8 and -6. So it is located somewhere over here. I'll be putting a solid dot over the number -7 because there is a little dash right below the inequality sign. Once the solid dot is put on the number -7 on the number line, I really need to figure out whether the dashed arrow will be pointing to the left of number -7 or to the right. In this case, the pointy tip of the inequality sign is pointing to the left. So all I really need to do is dash out this portion over here and draw a little arrow to symbolize my answer, and then that's it. Now if I pick some number such as -9, which lies to the left of number -7, I can read this inequality as -9 is less than or equal to the number -7. This is a true inequality because the number -9 is indeed less than or equal to -7. In this example, you are given the number line and the graphed solution of the inequality, and what you really need to do is figure out what the inequality was. So in this case, you can pick out any variable that you want, but I'm going to stick to the standard notation of the x. So I know that the x is my variable. The next thing that I really need to do is figure out on what number is there a dot. In this case, there's an open dot on top of the number 1. So I can simply write down the 1 right next to the x. The next thing that I really need to do is figure out, is the x greater than the number 1 or is it less than the number 1? In this case, the solution is all the set of numbers that are to the right of the number 1 due to the arrow pointing to the right of the number 1. So x is greater than the number 1. In this case, I don't put a little dash below the inequality sign because I have an open dot and not a closed dot. Another way that I can write this is by putting the 1 to the left. So I can say 1 is less than the number x. So this is another way you can denote the solution to the number line graph. Now in this example over here, we really need to figure out the inequality that satisfies the graph of the number line over here. So the first thing that I really need to do is pick a variable. In this case, I'll pick the variable x again. Next, I need to figure out what number goes with the variable. The number in this case is the number -6 because there's a mark on top of the number -6. So I write down the -6 like this over here. Next thing I really need to do is figure out whether or not my inequality sign will have a little dash below it or not. In this case, the inequality sign will have a dash below it because I am dealing with a solid dot over here. And lastly, I need to figure out whether or not my inequality sign will be that of less than or equal to or greater than or equal to. In this case, since my arrow is pointing to the left of the number -6, my answer will be less than or equal to. Now let's do one more problem where we have to actually derive the inequality from the word problem. So in this example, we have if Christina needs at least 85% on her algebra midterm to keep an A in the class, write an inequality that represents the given situation. Now the first thing that we really need to do is figure out a variable that we will be using. In this case, I'm going to pick the variable C to represent Christina's grade. The first part of this statement reads that if Christina needs at least 85. Now, at least 85 tells me that 85 will satisfy my inequality. So will 86 and any number that is bigger than or equal to the number 85. So when you have at least, you know that there will be a little dash in the inequality symbol. Now the only thing left to do is to write down the 85 over here because that is the base number that we're given, and figure out if my inequality will read C is less than or equal to 85 or C is greater than or equal to 85. In this case, since the terminology reads at least, it tells me that any number less than 85 will not be a part of the solution. So my inequality will read C is greater than or equal to 85. So there you have it. I hope you learned a lot from this video. I hope you keep on working hard, and I'll see you in the next video.